Good afternoon and welcome. In today's webinar, we will be exploring the rising use, risky combos, and better detection of cocaine. My name is Paul, and I'll be your moderator for today's webinar. Thank you for joining us. This session will run approximately 30 minutes, and it includes time for a live Q&A at the end. So please feel free to submit your questions through the Q&A feature at any time. Today's speaker is Dr. Gregory Hobbs, a board-certified clinical chemist with decades of experience in toxicology, laboratory medicine, and test development. Dr. Hobbs is nationally recognized for his leadership in drug testing and clinical screening advancements. Without further ado, please welcome Dr. Hobbs.
Thank you, Paul, and welcome to our webinar. This again is rising use, risky combinations, and better detection around that powder in that little Ziploc bag you're looking at with the hand model holding it, and that is cocaine. Next slide. So cocaine is a Schedule II drug according to the DEA scheme. Schedule 1 is high addiction potential, no medical use. Schedule 2 is high addiction potential, some medical use. And cocaine actually can be prescribed as a topical analgesic. Is very rarely prescribed. There's usually better alternatives, but cocaine can be prescribed. So that's why it's a Schedule II drug. It's a CNS stimulant, so it's an upper, and it can be used in a number of different ways by insufflation, which is a fancy word for snorting. And in the picture at the left, you see again the hand model with a razor blade setting up lines of cocaine powder to be snorted. It can be solubilized in some kind of a solvent, water, or what have you, and injected. It can be converted from the cocaine hydrochloride to the free base and smoked. And it can be taken the old-fashioned way. It can be rubbed into the gums like the Incas used to for centuries. They take coca leaves and rub them into the gums to help them overcome the difficult conditions high in the Andes where they had to do a lot of work. Next slide. So this is really a graph which appeared, the data of this appeared several years ago in the Lancet. And what these people did was to assign a score to various different street drugs and some drugs like tobacco and alcohol that aren't necessarily street drugs, a score to potential physical harm the drug can cause, and a score to the potential for dependence. And the drugs broke down into three categories: the yellow group, which is the least as far as physical harm and dependence goes; the orange group, which is sort of in the middle, like tobacco, alcohol, amphetamine, things like that; and then the red group. And that's the group of drugs which is most potentially harmful physically and is the greatest risk for developing dependence. And among those is cocaine. You can see the red arrow there. Cocaine is a dangerous drug. Next slide. So that danger has become even more pronounced in recent years. And this is data from Acutus, where each of these red boxes here represent samples that are positive for the indicated drug. And this is percent positivity of cocaine in each one. So if you look at all the alcohol positives, for example, about 13% are positive for cocaine. Of all the fentanyl positives, 50%, half, are positive for cocaine. Heroin, we don't get that many heroines anymore, but of the ones we do, we get 72% positive for cocaine. So what we're seeing is a lot of co-use in our patients that we serve, specifically with very dangerous drugs like alcohol and fentanyl, which we'll talk about in detail, and also ecstasy, and methamphetamine. So this is a pattern that's developed. Next slide. So what happens to you when you co-use cocaine with some of these other drugs? Well, with fentanyl and heroin, which were both opioids, it turns out quite a lot. So people usually use cocaine along with fentanyl to help them stay awake and help prolong the high of fentanyl so they won't just fall asleep. Same thing with heroin. What this combination can do, in addition to keeping them awake, however, is to also mask some of the signs of overdose so that people can be overdosing on fentanyl, but it won't be obvious because the person might still be awake and somewhat aware. And this can not only fool people who are around that person who might be able to render assistance, but also professionals who are trying to give clinical treatment. This has been done for quite some time with heroin, called speedballing, but with fentanyl, it's a relatively new combination, but the same principle is happening here. When you combine cocaine with alcohol, you can have to deal with liver toxicity, and most importantly, the formation of a metabolite called cocaethylene. We'll talk about this a little bit more, but it's a toxic compound, and it increases cardiotoxicity, among other things. Combining MDMA, which is ecstasy, or methamphetamine with cocaine has basically sort of extenuates the pattern with uppers. So you get severe hydration, hyperthermia, you get hot, you have increased heart rate, cardiovascular strain, elevated risk of heart attack and stroke, psychosis. There's quite a few things that happen when cocaine is used in combination with ecstasy or methamphetamine. Next slide. So this shows the increase in death rates after overdose with cocaine involved. And you'll see around 2013 that the rates are relatively low and haven't changed much for several years, about 5,000 in 2013. And then after that, you see an increase all the way up to 2022, and you have 27,569. So overdose death rates involving cocaine increased fivefold over that time period. The yellow line is cocaine in combination with synthetic opioids other than methadone. So this is almost entirely fentanyl. And you can see the light blue line is just overdose involving cocaine alone. There is a slight increase there, but almost all of that increase is driven by co-use with cocaine and fentanyl. Next slide. Okay, let's look a little bit at cocaine and ethanol. When you use cocaine and alcohol together, it decreases the metabolism of cocaine. So what happens is the concentration comes up as you use it, then it falls, and when you go to use again, it rises because it doesn't fall as fast when you're using alcohol. And so it'll stay higher, and as a result, the overall cocaine concentration in your blood will stay higher. And what this leads to is a higher heart rate, higher blood pressure, higher cortisol than you would get otherwise with either drug alone. The other thing you get is a decreased cerebral perfusion. There's less blood to the brain. And that's important because a lot of these overdoses that lead to fatalities, the terminal event is a seizure, and probably involved in this decreased cerebral perfusion. Neurobehavioral performance is reduced, so that's response to stimulus. But you do get an intense euphoria for it, more intense euphoria than with either drug alone. The main culprit in all of these is cocaethylene. Cocaethylene is significantly more lethal than cocaine alone. Next slide. So this is a study done many years ago now. by a group that published in Pharmacology, Biochemistry, and Behavior. And what they did was look at cocaine and ethanol. And they looked at rats. This is a lethal dose study. We don't do lethal dose studies in people. But what they did was take one group of rats and give them a constant dose of alcohol and a varied dose of cocaine. Another group of rats, they just gave a varied dose of cocaine, no alcohol. And they looked at what they call the LD50. That is the lethal dose, the dose at which 50% of that population dies. And what they found was that the lethal dose of cocaine was much lower when it was present with alcohol than when it was present without alcohol. About 56 milligrams per kilogram versus 73. Next slide. This is also a study. It's about prevalence, and it's very interesting because this came out a couple of years ago now from a group out of Sweden. It's published in Alcohol and Alcoholism. And what they did was go into clubs and bars and get volunteers to give them urine samples. And they tested them for ethanol and other drugs. And almost everybody had ethanol, obviously. But what was really shocking was 43% of the people who volunteered urine samples had ethanol plus cocaine. And that's shocking because cannabis is far more prevalent than cocaine is. But in combination, it was less prevalent in this population. Ethanol and cannabis, only about 23%, and ethanol and amphetamine, under 20%. But the ethanol, cocaine, much more prevalent, and that's part of what makes it dangerous on a population level. It's the prevalence of the combination of these two. Next slide. So we have an idea that demand for cocaine is increased from the overdose death chart I showed earlier. But there's other ways of looking at this. Again, that year 2013, this is illicit coca bush cultivation, this data from the United Nations. And you see 2013, the pattern is sort of in a nadir and then increases up until 2020 and then really takes off about 2020. This is a sophisticated market. It responds to demand very well. And you can see that illicit cultivation really increased dramatically over those years. Next slide. This is similar type of graph. Again, same source. This is pure cocaine production. You can see it hits about 2013, 2014, and then takes off, and then even has until 2019, and then again takes off again at 2020. Again, this similar pattern of increased demand of cocaine, increased overdose deaths of cocaine, and what we see is large and unexpected incidents of co-use of cocaine with other drugs, most concerning being fentanyl and alcohol. Next slide. We found this, I thought this was kind of interesting. I thought I'd include this in the talk. This is a paper out of JAMA from a few years ago actually now, where they looked at positivity of cocaine in different clinical settings. And it might not be surprising in the substance abuse, space, we're looking at about 9.5% positivity, and other types of practices are much less. Behavioral health is second at about 5%. So, a lot of people believe there's a kind of a link between behavioral health or behavioral health issues and substance abuse and vice versa. And there's more than a few patients who are probably being treated in both types of practices. So I thought that was kind of interesting to look at that. Pain clinics, OBGYN, this is sort of background. This is sort of around 2%, is sort of general population. So that's not particularly of concern with respect to those kinds of practices. Next slide, please. Okay, so we've got apparently increased demand for cocaine, increased use of cocaine, increased deaths associated with overdose of cocaine, especially in combination with other drugs. It's a big problem. So what are we going to do about it? What can the laboratory do about it? And from the laboratory viewpoint, we sort of work along payer and professional guidelines. So payer guidelines, ASAM guidelines, require us to perform a presumptive screen. And if it's positive, it automatically gets ordered to definitive confirmation testing. So that's what a reflex is, an automatic order. And the confirmation testing is definitive because it's more specific. So the initial screen for most drugs and for cocaine metabolite as well is usually an immunoassay. Now, an immunoassay is just a type of test that uses an antibody to bind to the drug or to the drug metabolite that we're looking for. And it has a cutoff of 150 nanograms per milliliter. So above 150 nanograms per milliliter is going to be positive, and below is going to be negative. But there's a problem because cocaine metabolite can be present below 150 nanograms per milliliter. So if it is, it'll just be reported out as negative. It will never be confirmed. And as a result, you won't see those patients between 50 and 150 nanograms per milliliter. Next slide. So Acutus came up with a solution. And that is, we developed a high sensitivity screen for cocaine metabolite. The high sensitivity screen has a cutoff of 50 nanograms per milliliter versus the 150 for the immunoassay. We've been doing this for about a year and a half now. And as we look back on our data, it appears that about 32%, full third of all the positive samples we have for cocaine metabolite were missed by the immunoassay versus our high sensitivity test. Next slide, please. So what does this mean clinically? Well, what it means is that as the cutoff gets lower, the detection times get longer. So once upon a time, the immunoassay had a 300 nanogram per milliliter cutoff, and you only were able to detect for about 30 to 35 hours, so less than 2 days between the time of use and the time of collection of the sample. When the cutoff dropped to 150 nanograms, this improved the situation somewhat. You can see between, let's say, 2 to 3 days after use. The red line is ours, and we estimate that at a 50 nanogram per milliliter detection window, we're seeing at about 120 hours or 4 to 5 days after use. What does this mean? This means that as a patient, if a patient uses over the weekend, you're much more likely to be able to detect that use during the week when you're testing them. Next slide. So we actually looked at this and compared the immunoassay directly to our high sensitivity test. We took samples between 50 and 150 nanograms per milliliter. That is the new cutoff and the old cutoff. And tested them by immunoassay. And it turns out that in that range of concentration, about 80% of those samples were not detected at all by immunoassay. So we're missing quite a few samples by looking at immunoassay. Next slide, please. Okay, so to sum up, cocaine appears to be surging in popularity. We saw the increase in overdose deaths. We saw the increase in cultivation. We saw the increase in powder produced. Cocaine, we know, is a very dangerous drug, highly addictive, potentially very harmful, especially when used in combination with other drugs. It appears that this combination use is really what's driving the increase. It's driving the market for cocaine and resulting in increased death rates. we believe that with more sensitive testing in that initial screen, that we can help improve treatment by extending the period after use that cocaine can be detected. So that's the end of the presentation. Thank you very much for your attention, and thank you for coming along, and I'll be happy to take questions now.
Thank you, Dr. Hobbs. At this time, we'll be taking the next few minutes to answer selected questions that have been asked by our attendees. We'll just give it a couple seconds here. I see that we have some questions already lined up here. Dr. Hobbs, you can feel free to look at some of the questions here and provide your
Yes, I'm looking at them right now. Okay. When clients deny recent use, but a low-level positive shows up, especially for cocaine, how should we interpret those results in terms of cutoff sensitivity and window of detection? Well, low level of any drug, but let's keep it on cocaine because that's what the talk's about, could mean a couple of different things. It could mean either there was a low dose, low level of use, or it could have been done recently, or it could mean higher level of use but done several days ago. So our detection can go 4 to 5 days at this cutoff, and so either way, it's a detection of use, and you'll probably see more of those. Now, I will say this: we do get requests for retest on these low cocaine results sometimes, and we have never had one that doesn't retest positive, and retest positive every time by definitive testing. Let's see. Can enhanced screening help us distinguish between new use and residual metabolites from earlier use, especially for cocaine? It depends on what you mean by new use. Really, with cocaine, they're all sort of new uses because cocaine doesn't stick around in the body for weeks at a time. Again, with the high sensitivity test, you can go back about 4 to 5 days, but you're not going to see, if you test somebody every week, for example, or every 2 weeks, you're not going to see old use. That is, you're not going to see, if you test on Thursday this week, you're not going to see use from Thursday the week before. Can enhanced screening help us distinguish between new use? Oh, I just read that one. Forgive me. Does cocaine clear our systems faster than some of the opioids, fentanyl and heroin? Normally, yes. You can see fentanyl and, more importantly, norfentanyl probably up to about 3 or 4 days. So typically, if somebody uses fentanyl, they will be positive for fentanyl for maybe 3 days or so, but the norfentanyl will still be present in the urine for maybe a day or two longer. Cocaine generally clears out a little sooner than that, but we do see them. We do see them together quite a lot. So half our positive fentanyls have cocaine present. But generally, if you were to keep following that patient, the cocaine would probably go negative before the fentanyl metabolite would. You mentioned that you are seeing increased use of cocaine with opioids. Is there a way that a lab can provide this data on a macro basis so that we can better see what is happening at our clinic? Yeah, we have a lot of capabilities, database capabilities in that regard. So I would work through your salesperson, work through our customer service group. We can provide data on location, by client, by zip code, by state, by national data. And all of those might be helpful to compare exactly where you're at. So absolutely, we can help you with that. Are there any other trends that you're seeing in the SUD community that you can share that we should be aware of? One that's interesting, and I didn't get a chance to show the data, but one that's interesting is this. If you look at, excuse me, if you look at substance abuse clients by prescription, and you break them down by Suboxone, methadone, and naltrexone, you'll find that the methadone patients with methadone prescription have a much, much higher positivity for cocaine than Suboxone or naltrexone. And that's interesting. And I don't know if that says something about the medication itself or it says something about the demographic of that particular patient that's on methadone. That part we is difficult to separate. But that is an interesting observation that we've made just in looking at our data.
All right. Thank you, Dr. Hobbs. And thank you to everyone who joined us today. If you'd like to speak directly with Dr. Hobbs or learn more about our toxicology testing, we invite you to schedule a time on our calendar. The link will be in the chat, and it will also be included in the follow-up email. A recording of today's session will be shared with all the registrants as well. On behalf of Dr. Hobbs and the Acutus team, thank you again, and we look forward to continuing the conversation.